in this video we are going to talk about the electron configuration. Okay, so first thing I need to talk about shell, subshell, and the orbital. Now shell is the place where electrons orbit around the nucleus. This is a shell and it has electrons orbiting around the nucleus. This is a shell and we have electrons orbiting around the nucleus. Now subshell is one or more orbitals in an electron shell. So this is a subshell and this is a subshell. Okay, so 1s is a shell. This is 1s, it's a shell and an orbital. And 2s is a subshell. This is 2s, and 2p is a subshell. This is 2p. If we add 2s and 2p, we get one shell, because if we add subshell, one subshell, we add it with another subshell, we get one shell. Okay, so let's write the electron configuration of the first element in the periodic table, which is hydrogen. Okay, hydrogen has the chemical symbol of H and the atomic number of 1. Now the atomic number shows how many protons are in the element. So if we have 1, we'll have 1 electron. So 1 proton, 1 electron, only if the element is neutral. If we have 5 protons, we'll have 5 electrons. Okay, so this is the structure of an atom for hydrogen. Okay, so first thing I'm going to use the Aufbau principle, which is a German word, Aufbau, and it means to build up. So here I'm going to build up. I'm going to start from the bottom till up. That's it. Okay? So let's start. Let me fill the orbitals. Now 1s will put an electron. Why? Because hydrogen has 1 electron. So we'll put in 1s orbital, 1 electron. And the arrow points up. It shows the spin of the electron. Okay, so the electron configuration of hydrogen is 1s1. So as you can see in the exponent, we have the number 1. Now, the number 1 shows how many electrons are in the orbital. So this is the electron configuration of hydrogen. Now let's take the second element of the periodic table, helium. And helium has a chemical symbol of He, and it has an atomic number of 2, so it will have 2 electrons. And this is the structure of an atom of helium. Okay, so let's write the electron configuration of helium. First thing, let's fill the orbitals. Now 1s, it's not full. Why? According to Pauli exclusion principle, says an orbital can fit maximum 2 electrons with opposite spin. Here we have 1 electron. We don't have 2 electrons. And so helium, as we said, has 2 electrons. So we put 1 here and another 1. So one of the electrons is pointing up and the other one is pointing down. That shows the opposite spin. Okay, so here we have a full orbital. Why? Because you have 2 electrons with opposite spin. Okay, so the electron configuration of helium, it's 1s2. Okay, the third element in the periodic table, it's lithium. It has the chemical symbol of Li. So lithium, it has an atomic number of 3, so it will have 3 electrons. And the structure of an atom of lithium is this. As you can notice that we finished the first shell and we moved to a second shell. Okay, so let's write the electron configuration of lithium. Let's start by filling 1s. We filled it with 2 electrons. So from 1s we go to 2s. We fill 2s with 1 electron. So we write the electron configuration of lithium as 1s2, 2s1. So this is the electron configuration of lithium. Okay, now the fourth element in the periodic table, it's beryllium. And beryllium has a chemical symbol of Be. And it has the atomic number of 4, so it will have 4 electrons. Now this is the structure of an atom of beryllium. Now before I continue, I must fill first thing this electron, then this electron. Okay, so let's write the electron configuration of beryllium. Okay, let's start from 1s. 1s we fill it with 2 electrons, so the orbital is full. We're going to go from 1s to 2s, so we fill 2s with 2 electrons. Okay, so the electron configuration of beryllium is 1s2, 2s2. Now, the fifth element in the periodic table, it's boron, and it has the chemical symbol of B, and it has the atomic number of 5, and it has 5 electrons. Okay, so let me show you the atom structure of boron. Okay, now I want you to write the electron configuration of boron. You can pause the video and then I'll show you the answer. Okay, pause it now. Okay, the answer. First thing, let's fill the orbitals. 1s with 2 electrons, 2s with 2 electrons. Now we go to 2p. We fill it with 1 electron. So the electron configuration of boron is 1s2, 2s2, 2p1. So this is the electron configuration of boron. Now, carbon. Let's take an example of carbon. Carbon has a chemical symbol of C and the atomic number of 6. So it will have 6 electrons. And this is the structure of an atom of carbon. Okay, let's write the electron configuration of carbon. First thing, let's fill the orbitals. 1s, we fill it with 2 electrons, 2s with 2 electrons, 2p with 1 electron. What do you think, guys? Are we going to fill the first orbital or we'll continue to the second orbital? You're right, we're going to continue to the second orbital, so we're going to put an arrow here. If you're asking why, according to Hund's principle, it says every orbital in the subshell gets 1 electron before any other orbitals get 2 electrons and the single electron have a parallel spin. Okay, again, every orbital in the subshell gets 1 electron before any other orbitals get 2 electrons and the single electrons have a parallel spin. Okay, here we have a parallel spin. As you can see, they both are pointing up. Okay, so let's write the electron configuration of carbon. It's, sorry, wrong color. It's 1s, 2, 2s, 2, then 2p2. Okay, another example. It's nitrogen. Nitrogen has a chemical symbol of N and the atomic number of 7 and it has 7 electrons, and this is the structure of an atom of nitrogen. Okay, so let's write the electron configuration of nitrogen. First thing, let's fill the orbitals. 1s, we have 2 electrons, 2s, 2 electrons, 2p, the first orbital 1 electron, the second orbital 1 electron, the third orbital 1 electron. So the electron configuration of nitrogen is 1s, 2, 2s, 2, then 2p, 3. Okay, now let's take an example of oxygen. Oxygen has the chemical symbol of O and the atomic number of 8 and it has 8 electrons. So this is the structure of an atom of oxygen. Okay, so I want you to write the electron configuration of oxygen. Pause the video and then check the answer. Okay, so the answer is before I write the electron configuration of oxygen, I need to fill the orbitals. 1s I fill with 2 electrons, 2s with 2 electrons, 2p the first orbital 1, second orbital 1, the third orbital 1. Then we come back and fill the first orbital. So the electron configuration of oxygen is 1s2, 2, 2s2 2p. We have 4. So this is the electron configuration of what? Oxygen. Okay, I'm going to skip the elements and I will stop putting the electrons and drawing the shells. Okay, because I'm going to waste a lot of time. Okay, so we're going to skip till the element aluminium. Aluminium has a chemical symbol of Al, and it has the atomic number of 13, and it has 13 electrons. Okay, so let's write the electron configuration of aluminium. Let's start. First thing, let's fill the orbitals. So 1s we fill it with 2 electrons, 2s we fill it with 2 electrons, 2p we fill it with 6 electrons, then 3s we fill it with 2 electrons, then 3p we fill it with 1 electron. Okay, so the electron configuration of aluminium is 1s, 2, 2s, 2, 2p, 6, then 3s, 2, then 3p, 1. Okay, I'm not going to continue. I just want to tell you before I end up this video the exception of 2 elements, the exception of Hund's principle. So both of the elements, chromium and copper, chromium has a chemical symbol of Cr and copper has a chemical symbol of Cu. Chromium has 24, the atomic number of 24, copper has the atomic number of 29. So chromium has 24 electrons, copper has 29 electrons. Now when we want to fill the orbitals, first thing we fill 3p. Okay, when we want to fill 3d and 4s, first thing we start by filling 3d with 1 electron each orbital and then filling 4s. This is for chromium. Now for copper, we fill for each orbital 2 electrons and then we fill 4s. Okay, so in the next video, I'm going to talk about the S block, the P block, and the D block. We still have the F block, and S block can always fit 2 electrons. P block can always fit 6 electrons, and D block can always fit 10 electrons. So I hope you enjoyed this. Thank you for watching this video, and see you later. Bye.